Okay. All right, let's try some exercises of proof in predicate logic. And I'll just work through some of the exercises. 11.4D on page 392. We'll just do a couple and see what happens. Now, normally, with proof in predicate logic, as I've said before, it normally works in three stages. The first stage is you instantiate to get rid of the quantifiers. Then you do the proof as if they were, using the 19 rules we learned before we even started predicate logic. And then if there are quantifiers in the conclusion, as there are in this case, you will generalize to get the quantifiers back. There's going to be a slight difference in one like this, as we'll see. And the first thing you should notice is you can't instantiate at all in any of these. It's obvious why you can't instantiate here, because instantiating is getting rid of quantifiers, and there aren't any quantifiers. So you can't instantiate lines 2 and 3. Why can't you instantiate on line 1? Well, the answer is, if you remember, you can only instantiate when a quantifier is the main connective of the whole line. And so obviously this one is not going to be the main connective because it's not on the far left. But even this one, which is on the far left, is not the main connective because there aren't parentheses around here. If there were parentheses here, then it would be the main connective, but there aren't. So the scope of this quantifier only extends this far, and the main connective of the whole line is in fact the conditional. So because the conditional is the main connective, you can't instantiate. So what are we going to do? Well, we're going to have to try and do modus ponens, and in order to do modus ponens, we have to have this. Well, you can probably guess that we're going to generalize, and we're going to turn this into this on line 2 into the antecedent of what's on line 1. And of course, we're going to match the variable, because you can pick any variable x, y, or z when you existentially generalize to line 2. So we're going to make it match up, so it's a y. So we turned something that, I know Dan is good into something is good by existential generalization. And then we can do modus ponens. Of line 1 and 4. Now, we're going to try and get something involving C. Well, there it is. And we can't just do modus ponens here because, of course, this is the main connective. So we're going to have to instantiate this. And we're going to want to instantiate it to match that name H. Now, because it's a universal, we can match the name. If this was an existential, we couldn't because you'd have to use a new name that hadn't occurred before. But because it's a universal, we can universal instantiate and turn these Z's into H's. So we have BH and CH. By universal instantiation, line 5. Then we can do modus ponens again, modus ponens 6, 3, which gives us CH. And then we're one step away, and this is like the usual last stage of any proof. We're going to generalize. What kind of generalizing? Existential generalization, which is good, because universal generalization is the tricky one where you have to use U, remember? But existential generalization, that's fine. This is saying, like, Harold is cheeky becomes something is cheeky. And, of course, it follows. So that's X, and we can use Z because we can use any variable. Existential generalization, line 7. So there you go. There's that one. Now, let's try one where we're going to have to do universal generalization. I'm going to try question 20. Hope it's not too tricky for me. All right, so we have, now this has square brackets, so that means the scope of this quantifier is going to be the whole thing. So that's premise. Line 2 is universal, all m's are v's. And then the conclusion, and this is why I'm doing this one, because the conclusion involves a universal quantifier. And because it involves a universal quantifier, that means when we instantiate we're going to want to use the name U, because we know that we're going to have to universally generalize at the end. So let's go for it. That's U. So LU, then CU and MU by universal instantiation line 1. MU, then VU. That's going to be universal instantiation line 2. How are we going to do this? We're going to, let's try exportation to this one. Why do I keep changing L's into 4s? LU and CU, then MU. That's by, oh no, that doesn't work, does it? Because that's an ampersand. Okay. We're going to want to do something so that we start with an L and end up with a V. This is slightly trickier than I thought. I can turn this into an, I know, yes, that's what I'll do. Not L, U, or CU and MU. What I did there was I did implication, because this is a conditional, and I changed it into a disjunction, so we negate that one. Implication on line 3. As befits question 20, this one's a little bit more tricky. Then I'm going to do a distribution. So we're distributing this not LU, that's going to show up twice. By distribution, line 5. Then that's the way of getting rid of this pesky CU. I want if LU then MU, and then we've got MU then VU, and we can do a hypothetical syllogism. So the thing that's blocking that at the moment is the CU, and the way to get rid of it is to do this distribution and then simplification. So I want the one without the CU, so I want this side. Not LU or MU, that's simplification, line 6. Then I'm going to change it back into a conditional, LU then MU, by implication, line 7. 1, 2, 3, 4, 5, 6, yeah, okay. And now I can do the hypothetical syllogism between these two lines, hypothetical syllogism 8 and 4. That's LU, then VU. And finally, the last thing I'm going to do is get the quantifier back, and I'm doing universal generalization because it's a universal quantifier, and that's why we had to use the name U, because the only name that I will allow you to do universal generalization to is the name U. So that becomes LX and VX by universal generalization. Now, line 9. Now that one might have been easier because there was this little trick there that I was almost stumped on. That one might have been easier if we use conditional proof. And of course you can use conditional proof even with predicate logic. But what you want to be careful with is, I want to prove this, but you don't assume something with quantifiers, because if I suppose I started by assuming this, and then I ended up on the last line with this, what that would prove is if everything is L, then everything is V, which is not what we want to prove. We want to prove that all L's are V's, not if everything in the universe is L, then everything in the universe is V. So what you assume in this case is you assume something that the antecedent of something, which when you prove it, you can then universally generalize to make this. And long story short, you would assume LU. Now, remember, I said when we were talking about universal generalization that the only way to introduce the name U was either by universal instantiation, which is the way we did it here, or by assumption. You're allowed to assume LU because you can assume whatever you want. That's the good thing about assumption. Then I can do LU, then CU, and MU by universal instantiation, line 1. What am I doing? 5. Then I can do modus ponens, get CU and MU by modus ponens, line 4 and 3. Then I'm going to universally instantiate this, MU, then VU, universal instantiation line 2. Then I can simplify MU from line 5 because it's a conjunction. Then I can do modus ponens to get VU, modus ponens 6, 7. And then what have I got? I've got, when I go back to the real world, I've got if first line, first indented line, then last indented line by conditional proof 3 through 8. And then on line 10, I can universally generalize that to get this. And that actually, although we're using conditional proof, is probably simpler. Takes the same number of lines, but doing this implication and distribution and simplification, that was a little bit tricky. Here, every step is fairly straightforward. So actually using conditional proof in a proof in predicate logic turns out to make the proof a little bit easier in this case. Universal generalization, line 9. Okay, I want to do one more yes. Number 7, is it? Let's do number 27. Because we haven't really done any involving, so this is page 393, question 27. We haven't done any really involving quantifier negation. So let's do one involving quantifier negation. Oops, that should be a tilde there, not a x. And then the conclusion is, okay. Now, with this one, you should check, as you always should check, to see if you're going to need the name U. And you look here and you say, well, there's a universal quantifier in the conclusion, so I will need to use the name U. Well, no, you won't, because of this tilde. And what that means is that you're going to existentially generalize, which you can do from any letter, and then you're going to do quantifier negation. And in fact, there's always a rule of thumb that you should do existential instantiation first. Well, you can't do any instantiation yet, because in both cases the tilde is the main connective. So we're going to be doing a bunch of quantifier negation. So let's start by doing quantifier negation here. So remember, the tilde hops over the quantifier. It changes type from existential to universal. So that's quantifier negation line 1. I'm going to get it out of the way with this one too. Quantifier negation 2. Now we want to get B. Oh, this one's going to be pretty easy. Now, I could use the name U because both of these are universal instantiation, but I'm not going to need it. So I'm just going to use regular old little a. So I'm going to instantiate here, universally instantiate line 3. And of course, because I'm universally instantiating, I can match the name, BA and not AA, by universal instantiation 4. Then I could do one of two things. I can do De Morgan's law and change this into a disjunction, or I can do implication and turn it into a conditional. I like conditionals more, so I'm going to turn it into a conditional. So that's implication on line 6. And then you can see that I do modus tollens 7, 5, and that's going to give me not BA. And then I'm 2 steps away. And one of them is not universal generalization, which is good because I can't do it with A. It's going to be existential generalization. Make sure that it's an X, so I want this to be an X. Existential generalization, line 8. And then finally, quantifier negation. And once you've hopped this tilde over here, it becomes the universal that you see there. Quantifier negation, line 9. So even though there's a universal quantifier there, I don't have to universally generalize because I have to because the last thing I do is going to be hopping the tilde over there. You cannot universally generalize and end up with something where the tilde is out front. You can only generalize and end up with something where the quantifier is out front. So that means the last thing you have to do is move the tilde over there, which of course is going to change that. Same here, I can't existentially instantiate on either of these because the tilde is there. I can only instantiate once I've made the quantifier the main connective, which I have to do by moving the tilde, which changes those existentials into universals. Okay, a couple of examples for you there. You can email me if you want help with more. I thought we were running close to the time limit.